Don, Let Us Predict Consulting would like to thank you for the opportunity to work with your team on the demand forecasting solution at Corporación Favorita. We'd like to briefly reacquaint you with the project team. Fred's going to review the exploratory data analysis, which helped us direct the modeling for this project. He also served on the technical writing team for the formal report, which you were sent earlier this week. Carrie, our data visualization lead, who will be highlighting the cloud database, will also walk you through a demo of the executive dashboards and the mobile app for your finance and sales teams. Tim is our solutions architect, and Jeff is our data science lead. Tim and Jeff will summarize the various model approaches and the rationale behind our solution recommendations. And I'm Krista, and I serve as the project manager and also part of the technical writing team along with Carrie and Fred. The agenda for this afternoon will be a brief overview of the problem statement and the company data set, some insights into the company's new cloud database, a look into the predictive and the not so predictive variables used in this model, the model approach, and the outcomes along with the recommendations. After the recommendations, Carrie will show the model in action with a super exciting executive dashboard and mobile app demo. A short overview of the problem being addressed is there is a need for the company to improve item forecasting accuracy for both perishable and non-perishable food items to decrease the overall cost of goods sold to drive an increase in net income. The ability to effectively decrease waste will help control costs and will also create a positive impact on the Ecuadorian environment. We also recognize your employees' commitment to creating a better experience for consumers by having the right products in stock at the right time. I'm going to ask Carrie to provide an overview of the data set and the preparations the team used for the data modeling approach.
So the data that we used was directly from Corporación Favorita. I have a link included where the data can be accessed and downloaded directly. They provided 6 CSV files at a total of 4.56 gigabytes of data with 125 million rows. Obviously, that's a very large data set. So in order to work with it and so that we were all able to access the same data, exactly the same data set, we created a cloud database. So what we did for the cloud database is we actually hired a pro bono consultant in order to help us with that. So he was able to actually load all this data into a database onto the Microsoft Azure platform. And then he was also able to optimize the database for performance so that when we were pulling data down, it was much faster than it would have been otherwise, which helped us with exploratory data analysis as well as with the modeling process. Throughout the project, he also provided assistance as needed, such as creating new tables for the dashboards. So when we were done with the project and trying to put all this data into dashboards, it was just very slow. So we created some special tables specifically for those, and he was able to help with that as well. So this is a really great add-on for our project. So I'm gonna pass it over to Fred for exploratory data analysis.
So with the exploratory data analysis, our main goal is to really understand the data. And in doing so, we are trying to maximize our insight into the data set while uncovering kind of the underlying structure of the large data set we were working with. We started going in and digging around and trying to extract important variables and also importantly, test some of our assumptions prior to that modeling. And one of the areas that we looked at was the sales by geography. And to give you a little bit of background, Corporación Favorita has 54 stores in 22 cities. So we really wanted to understand performance at both a store and a city level to find potential opportunities for growth. For example, Quito has the highest number of stores and also the highest unit sales per location. However, Guayaquil had the second highest number of stores but was only ranked 11th out of the 22 locations or cities in terms of unit sales per location. So this was an example where we kind of need a little additional business and economic information to understand why this is necessarily the case, and also to allow us to make recommendations on how to increase those unit sales. But it does identify an immediate geography and location to start optimizing. And another piece of insight, actually, that was both interesting and kind of alarming, was that if you look at the visualization on the left, we see sales broken down by city. And this is all time, meaning from the beginning of 2013 when we had access to the data all the way through mid-2017. As you can see, the sales are up and to the right. Usually a strong indicator makes executives feel pretty good about their progress. But if you look at just the 2017 data, what we see is pretty much across the board, every city is stagnant in terms of sales. And there are actually a couple cities that see a decrease in sales. So this is something that was really important. And if you want to talk in terms of visuals that really signify the importance of us creating a very strong model and why we're spending the money to do it, this is definitely the slide that helps point that out, especially given the stagnant growth that we're seeing in those cities. We also chose to look at promotions, and in doing so, we found that there was a statistically significant difference in sales when items were on a promotion and when they were not. And this went across this was the case for both overall data set and for almost all of the product families. When we dug into this a little bit further, we also looked at day of week information and found that weekends tend to perform better. Not too surprising, as people typically have a little bit more time to get to the store, but Thursdays perform the worst. And when we overlaid that information with the promotions and day of week information, Thursday coincidentally also had the fewest number of promotional items. So this is a potential indicator for you that the sales and the decrease in sales on Thursdays could be due to the fact that they held fewer specials during those days.
Thank you, Fred. I'll be talking today about two external factors that are believed to have strong influence on the overall sales. The first of which is oil, and the second of which is the earthquake that occurred. So jumping into oil, as with many countries located in Central South America, Ecuador's economy historically has been heavily reliant upon oil. One way that we can quantify this, the reliance on oil of the overall economy, is measuring the total revenue that's generated in oil and as a proportion of the country's overall GDP. This is an exercise that's regularly performed by the World Bank. Looking to the results in 2012, we saw that 17.5% of Ecuador's GDP was directly attributed to oil, making this the second most oil-dependent country in all of the Americas. To put some context here, by contrast, less than 1% of the GDP in 2012 was attributed to oil in the United States, and the average around the world was 2.5. So a significant reliance. Definitely seems that there could be some correlation here between the overall strength of oil prices as compared to how the economy is doing, ultimately leading to a higher number of sales for Corporación Favorita. However, when we looked at 2016, there was a significant shift where the proportion of oil revenue to GDP decreased all down to 13.7. That was a significant decline. Also, we were identified that Ecuador had additional access to capital, so this helped mitigate a lot of the risk that was associated with dramatic drops in oil prices. So we started seeing some clear indicators that maybe this reliance wasn't as significant as we once thought. One way to quantify this reliance is just simply by looking at the time series of the two. Initially, if you just compare oil prices to the change in sales, you don't clearly identify any significant trend here. And so that, again, kind of helps reiterate that we didn't believe that this was as valuable as maybe we once thought, or as our hypothesis said. If we take that a step further and actually calculate the correlation between these two time series, or the cross correlation, excuse me, we get a Pearson's correlation coefficient value of negative 0.071, which that negative correlation would actually indicate that increases in oil prices would lead to a decrease in sales overall. So that is directly counter to what our hypothesis is. So there are a few limitations to this overall approach. One thing to note is there could be a lagged relationship between these two variables that we can't fully identify, as well as, while sales may not show a strong relationship, prices may show a stronger relationship, as more expensive premium items may perform better during economically prosperous times. And ultimately, the relationship may become stronger, or we maybe always identify a stronger relationship over a longer period of study that could be something that we would evaluate in the future for predicting sales over a longer span, but not directly related to the task at hand. So with these results in mind, we believe that oil prices will provide little predictive value to our overall objective, and that's why we elected to exclude them in our overall modeling process. The next slide I'll talk about, or the next external factor I'll talk about, is the earthquake that occurred in Ecuador on April 16th, 2016. A magnitude 7.8 earthquake occurred on the northern coastal region of Ecuador, with an epicenter just 110 miles off of the capital city. Why this is important to talk about here is, during this period directly following the earthquake, it was noted that there was a significant rise in overall sales as the country rallied to purchase items that would help support those affected greatly by the earthquake, and just kind of an overall drastic increase in sales volume. To really better quantify this increase, to determine what the impact on variable selection and model development was, we explored the months both immediately preceding and following the earthquake in great detail, while comparing the 15 days immediately prior to the earthquake and 15 days post of the earthquake. There was a roughly 20% increase in overall sales following the earthquake. And then taking that a step further, we did identify a number of categories that saw the largest increase. You'll see here in this chart that home appliances saw a 275% increase when comparing pre-earthquake to post-earthquake 15-day periods, albeit that comes from a pretty small base of 103 sales pre-earthquake. But if you note the two highlighted sections here, grocery 1 and beverages, you see a 40% and 27% increase respectively, and they're coming from a much stronger base. These are some of the bigger categories. So, I mean, ultimately what this does tell us is that there was a huge increase in the overall sales volume after, and that's something that we need to be able to identify and control for in our model and our overall training set. However, that isn't something that's very valuable to us on a predictive basis, because earthquakes cannot be predicted into the future. And so having a way to build that into the model is very challenging. It's interesting to look at this from the perspective of understanding or being able to place some prediction around what the categorical growth would be directly following a natural disaster. So that's why we found this information very interesting. But ultimately, again, like the oil prices, something that we elected not to include in our overall modeling process, as we believe it just increased complexity with very little value or no value in predictive power. And with that, I'll actually hand it over to Jeff, who will talk through our modeling approach and some of our results.
So in terms of the models, Let Us Predict wanted to consider a wide variety of model types. So we included some complex algorithms such as regression models and decision trees, as well as relatively simplistic models like the moving average. A brief summary of some of the prep work that had to be done before we could apply any machine learning algorithms. So one thing that we had to do was label and code all of our categorical variables. For example, a computer can't recognize the word milk, and therefore can't use that data in any form in any form of modeling. So we had to convert all of these categorical variables into numerical values. Another thing that we did was we converted the items and stores into dummy variables. And a dummy variable is a binary value which takes a value of 0 or 1 to indicate the absence or presence of a categorical variable. For example, if we had 4,000 items, each item would be given its own category, and for those items such as milk, it would be represented with a 1, indicating this observation is for the item milk. And lastly, we did log transformation on the dependent variable unit cost. So in order to apply some of the regression model techniques, one of the prerequisites for this is that the dependent variable resembles a normal distribution. So using a log transformation helped our data become more closely matched with some of these assumptions. Now, in terms of the models themselves, we did 7 total models. So let's talk briefly about each of the models. So the first is a naive prediction forecasting model, which is a special use case of a moving average forecasting model where only one period is used for smoothing. The model can also only forecast up to one period in the future. Then we have a simple weighted moving average, which we'll talk more about in a second. We have random forest, which is which uses an ensemble learning method for regression and classification modeling developed by creating multiple decision trees. It's an algorithm that selects predictors at random and then repeats the process to create trees, which then allow the randomly selected predictors to average themselves into a single outcome. Then we've got Bayesian regression, which is a regression model using a technique similar to ordinary least squares with the coefficient weights slightly shifted towards 0. And Bayesian models are very flexible and accurate in small sample sizes. We have neural network, which is a powerful computational data model, which can detain and characterize complex inputs and output relationships. Neural networks acquire knowledge and can represent both linear and non-linear relationships and can learn directly from the data being modeled. Then we have gradient boosted decision trees, which is a machine learning approach that can be used for regression and classification. It uses decision trees that is created by iteratively learning in a stepwise progression using errors of a previously fit tree. And lastly, we have the ensemble method, which we'll spend a little more talking about along with the simple weighted moving average. So these are our 2 featured models, the simple weighted moving average model as well as our ensemble model. So a simple weighted moving average model in general is a simple moving average that takes an average of a rolling window. So the values during the calculation window will all be treated equally. However, values outside the window will not have any impact on the final output. Its strength is in its simplicity and ease of implementation. It is very quick and not computation intense. It is also very easy for all the stakeholders and business units to understand. Its drawbacks are that by its nature only looks at the most recent data and does not factor in any complex modeling scenarios such as seasonality. Then we've got the ensemble method. So we use a stacked ensemble model which combined the predictions from all 6 of the other machine learning algorithms. So ensemble modeling is a method for improving prediction accuracy by averaging out noise and reducing any overfitting from any single model. We ran 6 different models of various types, and our ensemble took the average predicted value from each of those models to create a 7th model. This helps to eliminate outliers where one model's prediction may have been way off. When looking how the ensemble model compared to the other 6 models, when comparing to the actuals, we found the ensemble model was never the best fitting model. However, it was also never the worst. The pros of the ensemble method is a very balanced output. In addition, since it uses calculation from 6 different models, it takes into consideration the complexities built into each model and can account for various impacts of the predictor variables. Its drawbacks, however, are in these complexities. It can be very difficult to understand the models and exactly how the calculations are being made, making it very difficult to get stakeholder buy-in. Now for the model results. So the metric that we used to compare the model results was the RMSLE, which stands for the root mean squared logarithmic error. It is a commonly used metric to evaluate the difference between our modeled results and the actual results. Since our ultimate goal is to optimize margin, we like the RMSLE metric since it more harshly punished the underestimates, and none of us want to leave money on the table. With the RMSLE, lower scores are better, And we can see from the graph that the ensemble model outperformed all 6 other models, with the simple weighted moving average scoring 5th and random forest bringing up the rear. When factoring in real sales compared to the actuals, we found something interesting. Despite a 5th place finish for in the RMSLE for the simple weighted moving average, it actually resulted in a higher net sales when compared to the actuals. This told us 2 things. It told us that 1, more recent sales had much greater predictive power than older results. And 2, despite correlation to sales from some of our predictive variables, such as the on promotion, the number 1 most powerful predictor were recent sales, and the other predictors did not have as much predictive value. So in conclusion, this leads us into the 2 different winners. So we've got the ensemble method, which gave us the best model metric in terms of accuracy. However, the simple weighted moving average resulted in the highest net income, giving it the prize as the best financial performer. So our recommendations are to implement the simple weighted moving average model since net sales is key, and we don't want to leave money on the table. And since that gave us the highest gross income, we want to make sure that we implement that model into our predictions. Next, we want to use a server to be able to store and run these models, something that's powerful and can run these in real time, and then push the results to our dashboard application. We want these dashboards to be automated so that they can also be accessed on the mobile app. We want finance to model the accuracy of the variables, and we want to model this in 6 and 12-month intervals.
Thank you so much, Jeff. For the last section of our presentation, I'm going to go through some examples of the dashboards. So in the deck itself, I have just a few screenshots to provide examples of what are in the dashboards. However, this is not where we're going to spend the bulk of our time. And then here's a mobile one as well. We're going to spend most of the time for the dashboards going through an actual demo. So the first one that's on the screen is the executive dashboard with all of the raw data that is coming from the database. So by raw data, I mean the actual numbers, not any transformations really on these numbers. So what this is showing is the sales, profit margin, gross profit, and sales per item for overall. This is set right now to 2017. So this is actually showing year to date through July 2017, the most recent full month that we have available. As well as a category analysis of those same 4 metrics. The categories that we chose to show on the dashboard are these 5 here. The reason we chose those is because they make up 80% of the sales just in those 5 categories. So they are definitely the most important ones for an executive to be monitoring. They can absolutely make or break what's going on for that particular month. And then finally, we're looking at it by stores. So there are 5 different specific store types in Corporación Favorita. And so within these, this gives you a breakdown of what's going on for each of those individually. This is a very high level look. It's meant for an executive to get an idea of what is actually going on in real time for now. So there are some other features available, such as being able to hover over and see, what exactly is going on in each month on the trend lines and things like that. So, and you can hover over and see some detail there as well. However, just looking at what's going on year to date, for example, is not the full story. Usually you want to see, okay, well, great, I see that our sales are a certain number, but is that up or down compared to how we've been doing in the past? So what this dashboard gives a year-over-year comparison for the year to date. So again, for this, for what we're showing here, this is through July 2017. And so you can actually see that sales are up 10%, 2017 over 2016, gross profits up 25%. Some really great metrics here. It also has the same breakdown by item family with those same 5 really important categories, as well as the 5 store names. So all of these metrics are just available at a glance instead of having to kind of make these calculations in your head on the fly. Also, again, this is for an executive level view versus someone who's really in the weeds on this data every day. This is just to get the high level I'm about to walk into a meeting. I want to make sure that I know exactly how we're performing. However, it is important for people that are constantly looking at more granular metrics to have access to data as well. So for this, we've created a separate sales and merchant dashboard for the sales and merchant teams to use. So for example, I'll go through a couple of use cases with this one just to show you. So I'm going to start with a merchant example. So a merchant's going to be a person who's in charge of an entire item family or a group of item families, depending on how the company is set up. So the merchant might be able to say, okay, where's my category and what are my sales for the year to date? They can scroll down and see the monthly trend in those sales. And then also have this dynamic scatter plot at the bottom. And we're going to talk a little bit more about that one in a second. So what makes this really powerful is, let's say that you are the merchant in charge of grocery 1. You can click on grocery 1 and let the data load for a second. When you do that, all of the data is going to update in order to reflect only grocery 1. So as you can see, the trend line didn't change dramatically, but it definitely is only reflecting grocery 1 since the scale decreased. You can also change this to where you're not only can look at sales, but you also could look at gross profit, for example, or average sales per store, or the average number of promotion days that you have on your grocery 1 products. So a lot of flexibility there. And then lastly, we'll take a closer look at this dynamic scatter plot at the bottom. So what we're looking at here with this particular view are sales on the y-axis and average sales per store on the x-axis. Each of these dots on the scatter is representative of a specific item within the grocery 1 category. Then the color of the dot of the scatter is based on average promotion days. So some items had 0 promotion days, and then some items have an average of 17.6 promotion days in 2017. So we can see that, for example, this top item, number 1157329, had by far the highest sales and the average sales per store, as well as the highest number of promotion days. So it's highly likely that those are linked. We can also see that there's, it seems to be based on how the colors get slightly darker as you go up, some sort of loose correlation between average promotion days and the average sales per store and total sales. Because as both of those increase, the colors do get slightly darker. Again, it's not a really strong correlation, but there might be something there. The reason that this is called a dynamic scatter plot is similar to the trend line. There's lots of things that you can change about it, but even more than the trend line. So I could change my Y to a different metric. I could change my X to a different metric. I could change what actually is being plotted and have the scatters be store instead of item, which we'll look at in 1 second. And I can also change what the color selection, what the coloring on the graph means. So let's look at another example here. We'll go back to all of the data. We can pick store name here. So this is going to be an example of, for example, if you were more of a sales manager and you were looking at sales on a store name basis instead of on an item family basis. So for this one, I'm going to pick Mega Maxi. And again, I can see my trend line down here. And then I can go down to my dynamic scatter plot. Obviously, this is a significantly different trend than what we were seeing before when we were looking at the various, at the grocery 1 item family. So on this one, let's look at, and then gross, I'm going to change this one to gross profit. I'm going to change the plot to store instead of item. So it's going to plot by, I have several Mega Maxi stores. So this is going to look at the actual store number 49, store number 47, for example, instead of the item. And then I'm going to leave this at average promotion days. So on this graph, you can see how there definitely is a correlation between gross profit and average promotion days, because the scatters get darker as they go up. And then there's also that really strong linear correlation between gross profit and sales, which is something that we would expect to see. So those are just a couple examples of going through this dashboard and how powerful it is. Obviously, there's tons of other things that you could see on this as well, but time permitting, I just wanted to show one example from a sales manager side, which is what we just looked at, and then one example from a merchant side. So another thing that we created were some mobile dashboards. So obviously on mobile, you're working with a lot less space. And so we had to really trim down the amount of data that we're showing, but I think we still got a really powerful view. So I know you can't really tell, but this is, the size, much more the size of a mobile screen. You would be able to pull this up on the Tableau app on your mobile phone, and it would be formatted and everything for that particular screen. So here, this is looking at an overview. So this is more like those top 2 executive dashboards that we were looking at, where you can you can pick a month or a year. Right now I have them all selected, but the data is only year to date through July 2017. So that's all that we're showing here through July. You can see total sales, as well as gross profit and sales per item and profit margin as well. So very similar to what we were looking at before. For the merchant team, as well as for an executive team, this is going to show at a high level what is going on for, right now we're looking at all of the item families in 2017, so sales, gross profit, and sales per item. But you could break this down and look at one specific category as well. So for example, grocery one, or sorry, Jeff, let's just take that out. Is that okay? Okay, so I'm going to start again on item family. Okay, so on item family, this is more for the merchant team. So here you'll be able to actually look at sales by year, as well as sales by one particular item family if you so chose to do so. So someone who's really interested in one particular family could pick just that one family and then see the same metrics just across that one piece. And then finally, we have a stores dashboard. So this is going to be comparable a little bit to the sales manager dashboard that we were looking at before, obviously much more formatted for mobile. Again, you can do a drop down for year and month. So right now I'm looking at July 2017 only. I can see the sales across all of the different store types. And then I also can use this as a filter in order to just look at the Mega Maxi stores, for example, if I wanted to. And then the size of the bubble is relative to the sales for that particular store. So this is, just a brief overview of the dashboards that we've made available. And then there's actually one additional bonus dashboard that we recently put together that just looks at the model and the actual data versus the model data, so that you could look at that by any sort of breakdown as well. So this is one that we've added since we turned in the final report, but I thought it was really important to be able to see and make those comparisons. So there's all different kinds of filters where you could filter this and look at the actual versus forecasted results. I am going to pass it back over to Krista to wrap us up.
Don, the entire team is looking forward to the implementation and integration phase for the model and the dashboard. We'll be following up with your finance and sales teams for the dates to get started, and we really appreciate your time this afternoon. And this is a let us wrap for us. We're so excited to get working, and thank you for your time.